SAT questions on transformations are quick points if you apply the rules properly. In this video, you will learn how to spot translations and reflection questions instantly so you can answer faster and with confidence. You can also get the graph answers easily without any calculation if you develop a keen observation mindset. When shifting a graph of a function, if you add a constant outside the function, then there will be a vertical shift. If c is positive, then the graph will go up by c units, and if c is negative, the graph will go down by c units. Similarly, if we add a constant inside the brackets in place of x, then there will be a horizontal shift. And be careful, when you add c, the graph will actually move to the left. And when you are subtracting c, the graph is going to move right. Now, let us observe and understand how linear functions can be shifted in the xy plane. So let there be a linear function f of x equals 2x, that is simply a line passing through origin. Now, if we add 3 outside the function f of x, then the graph is going to shift 3 units upwards. Or you could also understand this graph as 2 times x plus 1.5. So that is the reason there is also a 1.5 shift to the left. Similarly, if I subtract 3, then the graph is going to go down by 3 units, and that is also same as going 1.5 units to the right. Likewise, we could also apply translations on quadratic functions. Let there be a quadratic function f of x equals x squared plus 3, whose vertex is going to be 0, 3. Now, if I subtract 2 inside the brackets, so now x is x minus 2, the graph is going to shift to the right by 2 units. Hence, the vertex will shift from 0, 3 to 2, 3. Also, if I add 2 in place of x, then there is a shift to left. So the vertex will move from 0, 3 to the left to negative 2, 3. Now for the vertical shift, we simply add a constant outside the function. So if I add 2 outside the brackets, outside f of x, the graph will move up. So the vertex will shift from 0, 3 to 0, 5. The graph goes up by 2 units. Finally, if we subtract a constant outside, so if I subtract 2 from f of x, then the graph is going to move down and the vertex will shift from 0, 3 to 0, 1. If you multiply a function with a negative sign, then the graph would be reflected over the x-axis. Suppose there is a function f of x equal to x square. It's a simple parabola with origin as the vertex. Now we get the same parabola but inverted when I multiply x square with a negative sign. For example, if there is a function g of x and we apply translations and the new function is g of x plus 3 minus 2, that means the graph goes down by 2 units. So you could eliminate option C. And then adding a positive constant 3 would actually shift the graph 3 units left. Hence, our answer is A. For reflection of graphs, all we need to do is remember this table and switch the x and y coordinates accordingly. So whenever there is a reflection about x-axis, we simply change the sign of the y-coordinate. Similarly, if there is a reflection about y-axis, then we change the sign of the x-coordinate. If there is a reflection about the line y equal to x, then we interchange the x and y coordinates. Also, sometimes there could be questions where there is reflection about origin, then we have to change the sign of both the coordinates. And if there is a reflection about the line y equal to minus x, you interchange the coordinates and also flip the sign. For example, there is a triangle ABC with coordinates 3, 3, 5, 6, and 7, 3. So for reflection with respect to y-axis, we simply change the sign of the x coordinates. Similarly, if there is a reflection with respect to x-axis, we simply change the sign of the y coordinates. If we need to reflect a graph with respect to the line y equal to x, then we simply have to switch the x and y coordinates. Here, the point A has coordinates negative 2, 2. Now, the reflection of the same point about the line y equal to x would be positive 2, negative 2. All we need to do is swap the x and y coordinates. Similarly, we could do the same thing for the other points B and C. For example, if there is a line y equal to minus 2x equal to 2, and we need to reflect the line with respect to y equal to x, just like we have swapped the coordinates of points here, we need to swap the coefficients of x and y. If you look here, the coefficient of y is 1 and the coefficient of x is negative 2. Now, it will be the same equation in the same form, y, x, and the constant. But now, negative 2 would be the coefficient of y and 1 would be the coefficient of x. So, the reflected line would be negative 2y plus x equal to 2. So we got the answer, but still we need to look for a match in the options.